Good evening and welcome. Find a comfortable position, let your body settle, and allow yourself to simply listen. Tonight, we're going to explore the quieter side of our planet, the gentle processes that shape the Earth slowly, peacefully, over vast stretches of time. Let's begin with something called low-relief landscapes. Imagine a place where the land stretches out before you in soft, rolling waves, where there are no dramatic cliffs or jagged peaks, just gentle rises and falls. These are areas with small differences in elevation, and they're called low-relief landscapes. The surface looks smooth, almost calming to the eye. These peaceful terrains often develop in places where the rocks are relatively soft, or where the land has been worn down, quietly and patiently, for a very long time. There's something soothing about these landscapes, the way they seem to invite you to rest, to simply be. Now let's think about why some rocks create gentler landscapes than others. Soft, sedimentary rocks like clay and certain mudstones wear away more easily than their harder cousins. Picture water and wind, working year after year, century after century, slowly carrying away tiny particles. These softer rocks yield to erosion, creating broad valleys and gentle slopes instead of sharp, dramatic cliffs. When an area is dominated by these softer rocks, the entire terrain takes on a rounded, less rugged character. It's as if the Earth itself is choosing the path of least resistance, allowing itself to be smoothed and softened by time. There are also rocks that might surprise you with their gentleness. Take chalk, for example. Chalk isn't particularly hard, but it has a special quality. It's highly permeable, meaning rainwater doesn't run off the surface but instead soaks in, disappearing into the rock itself. Because there's so little water flowing across the surface to carve and erode, chalk forms smooth, gentle hill ranges rather than steep, jagged landforms. The water simply drinks itself into the stone, quietly, peacefully, and the landscape remains soft and rolling. Let's pause for a moment and consider the slowness of it all. Chemical weathering, the slow breakdown of rocks like granite through reactions with water and air, can take thousands of years, sometimes millions. Imagine that, a single boulder sitting quietly on a hillside, being transformed molecule by molecule, grain by grain, over time spans that dwarf human lifetimes. This is the essence of gentle geology, rocks quietly altering, changing, evolving over huge spans of time. There's no rush, no urgency, just the patient work of nature. Beneath your feet, right now, there is soil, and soil formation is one of the quietest processes imaginable. Rocks break down, bit by bit, and mix with organic material. Fallen leaves, decomposing plants, the remains of tiny creatures. This happens under calm conditions, without drama or violence. Over long periods, this gentle process creates distinct layers in the soil, each one a page in the story of how rock, water, and living things have interacted. If you were to dig down, you'd see these layers, a quiet record of time passing. Many of the rocks around us tell stories of peaceful places. Horizontal sedimentary layers, made of fine mud or silt, were often deposited in low-energy environments. Picture a quiet lake, or a broad floodplain where water moves slowly, or a calm, shallow sea. In these places, particles settled gently through still water, drifting down like snow, layer upon layer. These rocks capture evidence of gentle currents, the slow settling of sediment and water that barely moved. They're records of tranquility, frozen in stone. Sometimes, when sediments are still soft and newly deposited, they can deform in subtle ways. Under their own weight, or from a small earthquake, or from water moving through them, these soft sediments might fold or sag just a little. The result looks wavy, gentle, not sharply broken or fractured. These features reflect modest forces at work, nothing violent, just small adjustments as the sediment settles and compacts. Even the Earth's rearrangements can be tender. If you've ever picked up a smooth, rounded pebble from a beach or riverbed, you've held evidence of gentle persistence. Sediment grains that are well-rounded have usually been carried a long distance, tumbled by water, rolled by waves, or blown by wind. Each journey knocked off the sharp edges, bit by bit, until only smoothness remained. This rounding is a sign of abrasion that was consistent but gentle, repeated countless times over months, years, perhaps centuries. The stone becomes softer to the touch, polished by its long, patient journey. There are places on Earth where the geology is simply calmer. Regions far from active plate boundaries, where tectonic plates aren't colliding or grinding past one another, experience fewer earthquakes and volcanoes. In these tectonically quiet areas, changes to the landscape happen mainly through slow erosion and gradual deposition. The landforms here are often older, more subdued. They've had time to mellow, to be worn smooth by the elements. It's geology in its most peaceful state. And finally, let's think about what happens underground, where we can't see. Water moving through tiny pores and fractures in rock can dissolve minerals or weaken stone very gradually. This groundwater action is hidden from view, working slowly, patiently, in the darkness beneath the surface. Over long periods, this gentle but powerful process can create cavities, alter the rock's composition, and sometimes form caves or sinkholes. It's a reminder that even the most quiet processes can be profound, that gentleness and power are not opposites. Take a slow breath. Let these images settle in your mind. Smooth hills, rounded stones, water soaking quietly into chalk, layers of mud settling in a calm sea. This is the gentle side of geology, patient, peaceful, and endlessly transforming. Let's continue our journey through the quieter rhythms of the earth. Settle a little deeper into comfort, let your breathing slow, and allow these gentle geological stories to wash over you. Think about rivers for a moment. Rivers are sculptors, working patiently over unimaginable stretches of time. They gradually wear down mountains, carrying sediment grain by grain to lower areas, slowly transforming steep, rugged terrain into gentler valleys. This work takes millions of years. No hurry, no rush. When a river has flowed for a very long time, its character changes. Its course becomes broad and meandering, winding lazily across the landscape like a ribbon laid down by a relaxed hand. This is what geologists sometimes call the mature or gentle stage of landscape evolution. The river has softened its surroundings, smoothed the rough edges, created something peaceful. Now picture a floodplain. These are some of the flattest, most restful landforms on Earth. Floodplains form where rivers overflow their banks and spread out across wide, flat areas, leaving behind thin layers of mud and silt. This happens again and again, flood after calm flood, each one adding just a little more sediment. Because these deposits are laid down in relatively calm conditions, water spreading slowly, particles settling gently, floodplains become remarkably smooth and gently sloping. They're inviting spaces, these floodplains, places where the land seems to breathe easily. Let's move to the coast now. Sandy beaches are shaped by waves that roll in, one after another, endlessly moving sand grains back and forth. The waves sort the sand, round the grains, smooth them. This continuous activity, though persistent, is usually low and rhythmic rather than violent. The result is a wide, low-relief coastal strip that slopes gently into the sea. No sudden drop-offs, just a gradual transition from land to water. There's something deeply calming about that gentle slope, the way a beach invites you to walk slowly toward the waves. Inland, where the wind has room to work, sand dunes take shape. Wind blows sand grains along the ground, lifting them, carrying them short distances, then letting them fall to build mounds and ridges. Many dunes migrate slowly over time, creeping across the landscape grain by grain. This shows us how a persistent but gentle force like wind can reshape large areas without any sudden violence. Just steady movement, the patient accumulation of countless tiny journeys. In places where massive glaciers once dominated the land, melting ice leaves behind a different kind of gentleness. When glaciers retreat, they often leave broad plains covered with a mix of gravel, sand, and clay. These are called glacial outwash plains, or till plains, and they can be surprisingly flat and smooth. Even though they were created by once massive ice sheets, forces we might think of as powerful, the final result is gentle terrain, peaceful and open. Beneath these surfaces, something even more gradual is happening. Continents themselves can rise or sink slowly over millions of years. This movement happens because of changes deep in the mantle beneath us, or because of the weight of ice sheets or accumulating sediments pressing down. The vertical movement is often so gradual, so imperceptible in human time, that it only becomes noticeable when geologists compare ancient shorelines with modern sea level, or study rock layers that were once at different heights. The continents are breathing, rising and falling in a rhythm measured in millions of years. Picture a lake now. Lakes often rest in natural depressions in the landscape, basins where water collects faster than it can escape. Sediment settles quietly on lake bottoms, drifting down through still water, accumulating in thick, fine-grained layers. These layers can record hundreds of thousands of years of calm conditions. Each thin band representing a season, a year, a cycle of quiet deposition. Lakes are like geological libraries, their beds filled with pages of peaceful history. In the desert, there's a surface called desert pavement. In some arid places, wind slowly removes fine dust and sand, carrying it away particle by particle. What's left behind is a surface covered with closely packed pebbles, fitted together almost like tiles. This pavement forms very slowly and becomes quite stable and smooth once it's established. It represents a gentle, long-term balance. Erosion and protection reaching an equilibrium. The desert, often thought of as harsh, can create surfaces of remarkable smoothness and stability. On hillsides around the world, something is always moving, though you'd never see it happen. Soil and loose rock, what geologists call regolith, slowly creeps downhill. This process, called soil creep, is extremely slow, perhaps just millimeters or centimeters per year. But over decades, it can bend tree trunks as they try to grow straight while the ground shifts beneath them. It can tilt fence posts. This is gentle but persistent change, the hillside flowing like an incredibly slow river. And finally, let's think about river deltas, where rivers meet the sea and drop their sediment. In these deltas, thick piles of soft mud and sand accumulate over time. Under their own weight, these sediments slowly compact, and the surface gradually sinks, a process called subsidence. This sinking is usually very gradual, but over centuries it can lower the land significantly. And all the while, new sediment is gently being added on top, layer upon layer. It's a slow dance between sinking and building, subsidence and deposition, all happening at a pace that feels almost timeless. Breathe slowly. Feel the weight of your body supported beneath you. Imagine these processes, rivers meandering, sand dunes migrating, lake sediments settling, soil creeping down hillsides. All of it happening slowly, gently, patiently. The earth reshaping itself with no urgency, just the quiet work of time. Let's continue deeper into the quiet transformations that shape our world. Allow yourself to sink further into relaxation, and let these gentle processes unfold in your mind like a slow, peaceful dream. Deep beneath the surface, something beautiful is happening in the darkness. Many minerals form as molten rock, magma cools very slowly underground. There's no rush here, no sudden freezing. The cooling takes thousands, sometimes millions of years. And in that patient cooling, crystals have time to grow. Atom by atom, molecule by molecule, they build themselves into intricate structures, some growing large enough to see with your own eyes. These are the intrusive, igneous rocks, formed in stillness, without any dramatic surface activity, just quiet crystallization in the hidden chambers of the earth. If you've ever held a piece of granite and noticed the different colored crystals, quartz, feldspar, mica. You've held the result of this gentle, unhurried process. Now let's drift to the deep ocean floor, far from the turbulence of surface waves. Here, fine mud and tiny particles from living organisms sink down through the water column, settling millimeter by millimeter. It's like an endless, gentle snowfall in the darkness. Particles drifting down, landing softly, accumulating. Over millions of years, these calm water deposits pile up into thick sediment layers. Gentle burial and compaction slowly transform them. The soft mud becomes shale. The skeletal fragments become limestone. All of it happening in profound silence, in the deep, still waters of the ocean basins. Come back to the coast now, to the rhythm of the tides. Regular tides move water in and out, twice each day, every day, endlessly. This repeated, low-energy motion slowly redistributes sand and mud along estuaries and tidal flats. The water advances, retreats, advances again, each time carrying and sorting sediment, smoothing and shaping. Over time, this patient work creates broad, flat intertidal zones, places where land and sea blur together, where the boundary between them becomes soft and gradual. There's something meditative about tidal rhythms, the way they repeat, predictable and calm, shaping the shore with gentle insistence. Beneath the surface of these sediments, even after they've been laid down, change continues. This is a process called diagenesis. Chemical changes occur slowly as minerals precipitate from groundwater, cementing grains together. These subtle reactions happen grain by grain, pore by pore, gradually binding loose sediment into solid rock. There's no obvious disturbance at the surface, just quiet transformation underground, as soft sediment hardens into stone over thousands or millions of years. It's alchemy of the slowest, gentlest kind. Water itself is a quiet sculptor. Rainwater and groundwater contain weak acids that can dissolve certain minerals. Carbonates like limestone, some feldspars in granite. The dissolved material is carried away invisibly, atom by atom, in solution. You can't see it happening, but over time, this chemical weathering thins rocks, weakens them, transforms them. The surfaces left behind are often rounded and softened, as if the rock itself has relaxed, let go of its sharp edges. This is erosion at its most subtle, removing the land not by breaking it off, but by gently dissolving it away. Where rivers meet the sea, something peaceful unfolds. The river's current slows as it reaches the ocean, and all that sediment it's been carrying, sand, silt, mud, begins to drop. Layer by layer, the sediment accumulates, building up deltas. Over time, these become low, flat, lobed landforms that extend the coastline seaward. The delta grows slowly, steadily, as the river continues its patient work of delivering sediment to the sea, its creation through accumulation, land being born grain by grain at the meeting place of river and ocean. On some rocky coasts, there's a feature called a wave-cut platform. Waves at roughly the same water level, working for long periods, can plane off a narrow, nearly flat rock surface right at the shoreline. This platform is the result of long-term, repeated abrasion. Not a single storm or violent event, but countless waves, year after year, gently wearing the rock smooth and level. When the tide is out, you can sometimes walk on these platforms, flat as a table, polished by persistent water. Even living things participate in this gentle geology. Plant roots grow into cracks in rocks and soils, and as the roots thicken over the years, they widen those cracks bit by bit. It's slow but powerful, life-prying open stone. Microorganisms secrete acids that help break down minerals. Burrowing animals disturb and mix surface materials, bringing fresh rock fragments to the surface where they can weather. All of these biological actions contribute to the very gradual breakdown of rock, life, and stone interacting in a slow, cooperative dance. The earth beneath us is always seeking balance. When massive ice sheets melt, the crust that was pressed down by all that weight begins to slowly rise. When thick sediments accumulate in one place, the crust there gradually sinks. This is isostasy, the crust adjusting to maintain equilibrium. These vertical motions often occur over thousands of years, gently changing regional elevations without sudden movements. The land is breathing, rising here, sinking there, always seeking balance, always adjusting with patient grace. In the cold regions of our planet, permafrost, permanently frozen ground, responds to changing temperatures by slowly thawing and refreezing. This gradual cycle can cause the ground surface to heave upward slightly or to settle. Over time, this gentle movement reshapes slopes and changes drainage patterns in subtle, ongoing ways. It's geology shaped by ice that never really melts, by ground that's frozen most of the time, but still manages to shift and flow slowly, responding to the seasons and the centuries. Take another slow breath. Feel yourself becoming heavier, more relaxed. Think of crystals growing in darkness, sediment settling through deep water, tides advancing and retreating, roots widening cracks in stone. Everything moving slowly, everything gentle. The earth transforming itself with infinite patience, moment by quiet moment, through vast expanses of time. Rest in that slowness. Let it carry you deeper into calm. We continue our gentle journey. Let your eyes rest, your muscles soften, and allow these quiet stories of the earth to drift through your awareness, like clouds moving slowly across a calm sky. In certain parts of the world, limestone bedrock meets rainwater, and something remarkable happens very slowly. The rainwater is slightly acidic, just enough to dissolve limestone bit by bit. Over thousands and millions of years, this creates karst landscapes, broad sinkholes, gentle depressions, and underground channels that thread through the rock like hidden passages. These features don't appear suddenly. They evolve gradually, creating rolling terrain rather than dramatic cliffs. The land becomes pocked with shallow bowls, softly contoured hills, and places where streams simply vanish into the ground. It's a landscape shaped by dissolution, by rock quietly disappearing into water, molecule by molecule. Beneath your feet, soil is always being made. This process, called pedogenesis, happens through the slow mixing of weathered rock with air, water, and organic matter. Over time, distinct layers or horizons develop, each one with its own character, its own mixture of minerals and life. This patient work can take centuries, even millennia, to produce the fertile soil mantles that cover gentle slopes and support forests, grasslands, and farms. Soil is a bridge between rock and life, and it forms so gradually that we rarely think about it. But it's always there, always developing, layer by quiet layer. In the driest places, where water is scarce or absent, wind becomes the sculptor. Wind carries sand grains that gently abrade exposed rock surfaces, a process sometimes called sandblasting, though it happens far more slowly than that word suggests. Over long periods, this wind erosion rounds edges and creates features like yardangs, streamlined ridges, or ventifacts, rocks polished smooth on one side. The result is subdued desert landforms, polished and shaped entirely by air and sand, without water's involvement. These surfaces can have an almost glassy smoothness, testimony to millions of impacts, each one tiny, each one part of the patient work of wind. That same wind can carry even finer particles, silt so fine it stays suspended in the air for long distances. When this silt finally settles, it creates something called loess. Loess deposits form thick, uniform blankets over landscapes, sometimes covering vast areas with a smooth layer that creates gentle, rolling hills. These deposits often come from glacial outwash, fine material ground up by ice and then blown across continents. Loess is soft, easily eroded by water, yet it can remain stable on slopes for long periods. It blankets the land like a soft duvet, smoothing everything beneath it. Back at the coast, waves do more than just erode. They also build. Waves can deposit shingle and gravel in ridges that run parallel to the shore, forming low terraces that gently slope toward the sea. These are sometimes called storm beaches, and they accumulate slowly over many storm cycles, each one adding a little more material. The ridges mark past high water levels. subtle rises in the landscape that tell the history of where the waves have reached. It's construction through accumulation, building the coast, pebble by pebble. Deep underground, where we can't see, warm groundwater moves through fractures in the rock. This hydrothermal water alters minerals through quiet chemical exchange. No eruptions, no violence, just slow transformation. Over time, this process softens rocks, changing their mineral composition and preparing them for later, gentler erosion. It's geological preconditioning. The rock being changed from within, made more vulnerable, made ready for the patient work of weathering that will eventually bring it to the surface. Where mountain streams emerge from narrow canyons into broad valleys, they slow down suddenly. The water spreads out, losing energy, and drops its load of gravel and sand. This creates alluvial fans, broad, cone-shaped deposits that radiate out from the canyon mouth like an open hand. These fans build gradually, storm by storm, flood by flood, creating smooth aprons at the base of mountains. From above, they look like graceful skirts spreading across the valley floor. In the coldest regions, where the ground freezes in winter and thaws in summer, an interesting thing happens. Freeze-thaw cycles lift soil particles slightly each winter as ice crystals form and expand. Over many cycles, this sorts particles by size and creates patterned ground, stone stripes on slopes, or stone circles on flat areas. The patterns are remarkably regular, and they create gentle undulations on tundra surfaces. This happens over decades and centuries, with each freeze-thaw cycle moving things just a little, sorting them just slightly. But the cumulative effect creates order out of randomness. Not all faults move in earthquakes. Some faults slip continuously at rates of just millimeters per year. This is called aseismic creep, and it's slip without shaking. Features like roads or fences that cross these creeping faults get gradually offset, a little more each year. But there's no sudden drama, no earthquake. It's the earth quietly adjusting, releasing stress continuously, rather than building it up and releasing it all at once. A gentle compromise between movement and stability. And finally, in warm, shallow seas, tiny coral polyps and algae are building something vast. They slowly secrete calcium carbonate, creating structures that grow upward toward the light. Layer by layer, over thousands of years, they build reefs. These reefs form gentle lagoons, protected areas of calm water, and sometimes atolls, ring-shaped islands that encircle quiet bays. This is organic accretion, life-building stone, constructing landscapes through the patient work of countless small creatures, each one adding its tiny contribution to something that can eventually stretch for miles. Breathe, rest, feel the weight of time in these processes. Limestone dissolving, soil horizons forming, wind polishing rock, coral building reefs. Everything moving at its own patient pace. Nothing hurried, nothing forced. Just the gentle, persistent work of the earth, transforming itself slowly, beautifully, endlessly. Let that slowness settle over you like the loess settling over the land. Soft, even, peaceful. Let's journey onward through more of the Earth's patient transformations. Settle even deeper now. Let your body grow heavier, and allow these gentle geological rhythms to wash over you like a warm, slow tide. In the driest regions of the world, something solid is forming underground. Calcium carbonate, dissolved in groundwater, slowly precipitates out as the water evaporates in the heat. Bit by bit, this mineral cements soil particles together into hard layers called calcrete. These layers form flat, resistant caps on gentle slopes, taking thousands of years to develop. They're like natural pavements beneath the soil, quiet monuments to evaporation, to water rising and disappearing, leaving its dissolved cargo behind. The land becomes armored, gently, one molecule at a time. In the humid tropics, where heat and moisture work together year-round, intense but slow chemical weathering transforms the soil. Silica is gradually leached away by rainfall, leaving behind iron and aluminum compounds. Over time, these form laterite, hardened, iron-rich layers that can be several meters thick. Laterite creates stable, gently undulating plateaus with distinctive red or orange surfaces. Porous, resistant, ancient. These are some of the oldest soil profiles on Earth, shaped by millions of years of quiet chemical transformation in the tropical heat. In cold regions where permafrost lies beneath the surface, something fluid happens to the soil. During brief thaw seasons, the upper soil layer becomes saturated with water, but cannot drain because the frozen ground beneath it is impermeable. This saturated soil flows slowly downslope like thick syrup or honey. Not in a rush, not in a landslide, but in a gentle, continuous creep called solifluction. It produces lobed or sheet-like features on hillsides, reshaping the landscape without sudden movements. The hill is flowing, imperceptibly, like a slow-motion wave. In waterlogged lowlands, bogs and fens, dead plant matter accumulates faster than it can decay. The water prevents oxygen from reaching the organic material, so it builds up, layer upon layer, compressing gradually into peat. These layers can grow several meters thick over thousands of years, creating flat, spongy surfaces that gently bounce beneath your feet if you walk on them. Peat bogs are carbon storehouses, quietly locking away atmospheric carbon for millennia, one plant fragment at a time. They're soft, dark, and peaceful, wet archives of ancient plant life. In certain glacial lakes, something beautiful is recorded in the sediment. Each year, as seasons turn, different materials settle to the lake bottom. Coarser particles in the summer, finer clay in winter. These create seasonal layers called varves, colorful, paper-thin bands in the sediment, each pair representing 1 year. Varves can be counted like tree rings, and they record gentle climate cycles with millimeter-scale precision over centuries. Their calendars written in mud, quiet witnesses to the passage of time, preserving each year as a delicate stripe. On exposed rock surfaces, especially in deserts, a subtle transformation occurs. Dissolved iron in groundwater or moisture slowly oxidizes when it reaches the surface, painting rocks with thin patinas of red or brown. This is sometimes called desert varnish, and it's partly created by microorganisms that help concentrate the minerals. The coating is incredibly thin, just a fraction of a millimeter, but it adds a glossy sheen to exposed stones. This happens very gradually, over hundreds or thousands of years, as layer upon microscopic layer builds up. The rocks become adorned quietly by chemistry and life working together. In desert basins, shallow lakes appear during rare rains, then dry up under the intense sun. These are playas, and they go through repeated cycles of wetting and drying. When they dry, they leave behind salt crusts and distinctive mud cracks in intricate polygonal patterns. The basin floor is flattened and reformed with each cycle, a low-energy process of flooding and evaporation. Playas remain broad, level depressions, some of the flattest natural surfaces on Earth, shaped by gentle wetting and patient drying, year after year. Where hot springs bubble to the surface, they sometimes carry dissolved silica. As the water cools and evaporates, that silica precipitates out, forming a material called geyserite or sinter. This builds up around the spring vents, creating low terraces and cones, growing millimeter by millimeter. The formations are often smooth and pale, white or cream-colored, and they develop without explosive activity. Just steady deposition from warm water, creating sculptural mounds that look almost organic in their flowing forms. Deep beneath some ancient landscapes, chemical weathering can attack bedrock for millions of years, creating what's called an etch plain. This is a nearly flat surface that forms at depth, where chemical processes have broken down the rock uniformly. Later, gentle erosion removes the overlying soil, exposing this ancient weathered surface. Etch plains represent the end stage of subdued landscape evolution, a nearly featureless plain that speaks of unimaginable spans of time and patient chemical attack. They're among the gentlest landforms imaginable, flat, stable, ancient. And finally, think about rivers and how they move. River channels don't stay in one place forever. They shift sideways slowly through their meanders, eroding the outer bank of each curve, while depositing sediment on the inner bank. Over time, this creates broad, scrolling patterns in the floodplain, graceful loops, and abandoned channels called oxbow lakes. The river wanders back and forth across its valley, like a snake moving in slow motion, reshaping the land gradually through this process called thalweg migration. It's the river writing its history across the landscape in gentle curves. Rest now. Breathe slowly. Picture calcrete forming beneath desert soil, peat accumulating in quiet bogs, varves settling in still lake water, a river slowly carving new paths across its floodplain. All of it happening at nature's pace. Unhurried, patient, gentle. Let these images drift through your mind like the silt settling through lake water. Slowly, peacefully, finding their place. You're safe here, in this slow time, where nothing demands urgency and everything simply unfolds as it must. We drift further into the earth's gentle rhythms. Let yourself become even more relaxed, your breathing soft and even, as these quiet transformations unfold in your mind, like petals opening in slow motion. In arid and semi-arid zones, minerals dissolved in soil water create something hard near the surface. Silica, iron, or salts cement loose sediments together into tough crusts called duricrust. These thin, resistant layers form through endless cycles of evaporation and precipitation, water rising through the soil, evaporating in the heat, leaving its dissolved minerals behind. Over centuries, this stabilizes gentle slopes, creating a natural armor just beneath the surface. The land becomes encrusted, protected, hardened slowly by chemistry and sun. In the tundra, where the ground freezes and thaws with the seasons, the soil itself churns. This process, called cryoturbation, mixes the frozen earth through repeated expansion and contraction. It creates remarkable patterns on the surface, polygons outlined in stones or stripes running downhill, without any major displacement or violence. These are subtle surface mosaics, created through countless micro-movements, tiny adjustments as ice forms and melts, year after year. The tundra is patterned like fabric, woven by frost. Behind coastal sandbars or coral reefs, protected from the open ocean, calm lagoons fill gradually with fine mud and shells. The water here is still, sheltered, and sediment settles peacefully to the bottom. Over thousands of years, this lagoon infilling produces low-relief coastal marshes and shallow flats, places where land and water merge softly, where ecosystems thrive in the quiet accumulation of sediment. These are some of the gentlest transitions between ocean and land. At the base of mountains, where steep slopes meet flat plains, erosion creates something called a pediment. This is a broad, gently inclined surface of bedrock, beveled smooth by the slow action of water washing over it in thin sheets. Pediments form through centuries of sheet wash, water spreading across the surface rather than cutting deep channels, and through the gradual retreat of gullies eating back into the mountain. The result is a smooth transition zone, a ramp from mountain to plain, shaped by water that flows gently and widely, rather than cutting deep and narrow. In some canyons, groundwater does the work of carving. Water seeps from weak layers in the rock, emerging along cliff faces and slowly undercutting them. This process, called sapping erosion, forms alcoves and rounded valleys. Space is carved from within rather than from above. These quiet canyons develop without heavy surface runoff, just steady seepage removing rock grain by grain, creating subdued slot canyons with smooth, curved walls. The rock is being dissolved and carried away by water that barely flows, just seeps, persistently, patiently. Where warm springs emerge from the ground, sometimes they carry dissolved calcium carbonate. As the water flows over the surface and cools, that carbonate precipitates out, forming travertine. Layer upon layer, it builds stair-like pools and ledges, terraces that look almost architectural in their regularity. Travertine creates smooth, terraced slopes around springs, growing incrementally, rimstone by rimstone. The formations can be white or cream-colored, often with pools of clear water caught in their curves. its stone being built by water, slowly, beautifully. On hill slopes everywhere, there's a thin layer of weathered material, regolith, that's always moving. Under the influence of gravity, rain splash, and frost action, this loose cover inches downslope over decades. It blankets slopes with a mobile layer that responds to every frost cycle, every rainstorm, every small disturbance. Over time, this creep gently rounds hill profiles, making them more convex, softer in outline. The hills are flowing, so slowly you'd never see it, but they're flowing nonetheless. In desert regions near coasts or shallow water tables, evaporating seawater or groundwater leaves behind salt. These areas, called sabkhas, become salt flats that level and harden coastal depressions. Through seasonal flooding and drying, sabkhas form vast, mirror-flat expanses, some of the flattest surfaces anywhere on Earth. They can reflect the sky like glass when wet, or shimmer with salt crystals when dry. They're shaped by the simple cycle of flooding and evaporation, repeated endlessly, creating perfect flatness through patience. Scattered around the world, there are ancient erosion surfaces that survive as broad plateaus. These are remnants of peneplains, landscapes that were once eroded almost completely flat, reduced to minimal relief. They testify to near-complete landscape, flattening over tens or hundreds of millions of years. Peneplains represent the ultimate gentle reduction of once towering highlands to low, subdued surfaces. They're geological endgames. What happens when erosion has had almost unlimited time to work? Standing on one is like standing on the ghost of an ancient, peaceful world. And finally, even the smallest life shapes rock. Lichens and algae colonize exposed stone surfaces, clinging to cliffs and boulders. These microbes secrete weak acids that slowly etch and pit the rock, millimeter by millimeter, decade by decade. This biological weathering rounds sharp edges on boulders, softens the profiles of outcrops, creates subtle textures on rock faces. It's life-dissolving stone, not through force, but through chemistry, through persistent chemical conversation between organism and mineral. Over exposed lifetimes measured in centuries, the rock yields, become softer, more rounded, shaped by the patient work of living things. Breathe deeply. Feel yourself sinking deeper into rest. Think of salt flats spreading flat as mirrors, travertine terraces building pool by pool, regolith creeping down hillsides, lichens etching stone, everything moving at its own unhurried pace. The earth reshaping itself through processes so gentle they're almost invisible, yet so persistent they transform entire landscapes. Let that persistence carry you. Let it support you. Let it remind you that there's no rush, that time moves slowly and generously when given the space to do so. Rest in that slowness. Be held by it. We continue deeper into the earth's patient work. Let your mind grow quieter, your body heavier, as these gentle processes unfold like stories told in whispers. Around certain springs, where calcium-rich water bubbles up from below, something porous and irregular takes shape. As the spring water evaporates in the air, it deposits calcium carbonate in spongy mounds and natural dams. This is tufa, and it grows outward slowly, forming features that are low in profile but rich in texture. Over centuries, tufa creates wetland landscapes with pools and cascades, each one edged with this soft, porous stone. The formations are often cream or tan-colored, sometimes draped with moss. They grow organically, unpredictably, shaped by the flow of water and the chemistry of evaporation. In periglacial zones, where the ground is partially frozen much of the year, spring thaw brings slow movement. The upper layer of soil, saturated with meltwater, slides downslope in gentle sheets. This process, called gelifluction, produces smooth tongues or lobes of soil that reshape subtle tundra contours. There are no scars, no sudden failures, just slow, viscous flow that leaves the landscape softly molded, as if pressed by patient hands. The earth moves like thick cream pouring in slow motion. At the back of beaches, where storm waves reach during the highest tides, sand piles up into low ridges called berms. These are built during calm high tides, when waves wash up and deposit their sandy load just beyond the normal reach of the sea. Berms create stepped profiles along the coast, gentle risers that mark different tide levels. They migrate seasonally, growing and shrinking as storms come and go, as seasons change. Walking over them, you climb gentle sandy stairs that the ocean has built and rebuilt countless times. In some landscapes, isolated hills of granite rise from flat plains like islands in a calm sea. These are inselbergs, and they're shaped by a process called exfoliation. Outer layers of rock flake off like the skin of an onion, released by pressure as the stone expands slightly when erosion removes the weight above it. This creates bald, curvaceous domes that rise gently from their surroundings, smooth, rounded, almost sensual in their curves. They're monuments to the slow peeling away of stone, layer by patient layer. In estuaries, where rivers meet tides, clay particles settle in the quiet moments between tidal pulses. Each tide deposits a thin sheet of clay on the mudflats, raising them incrementally, millimeter by millimeter, tide by tide. Over years and decades, mudflats expand seaward, forming vast, level expanses that glisten when wet and crack into polygons when dry. Marsh plants eventually colonize them, their roots stabilizing the mud, and the estuary slowly fills in, land claiming what was once water, gently, persistently. In ancient sandy landscapes, especially in subtropical regions, silica-rich groundwater has cemented sediments into something remarkably hard. This is silcrete, a quartz-rich material that resists erosion and caps mesas with smooth, glassy pavements. The surface can look almost polished, reflecting light, harder than the sandstone it once was. Silcrete forms over vast periods as silica slowly precipitates from groundwater, binding sand grains into a nearly indestructible sheet. It protects the softer rock below, creating flat-topped hills that stand above the surrounding lowlands. In badlands, where clay-rich soils are easily eroded, water doesn't always cut deep channels. Sometimes it flows as a broad sheet across the surface, eroding in a more diffuse pattern. This creates washes, broad, shallow depressions between ridges. Over time, these washes widen gradually, softening the harsh badland relief into rolling pediments. The landscape becomes less jagged, more flowing, as the washes spread and merge. Even badlands, given enough time, can be gentled. In warm, shallow tropical seas, something curious forms. Calcium carbonate coats sand grains in concentric layers, creating tiny spheres called oids. Currents roll these oids back and forth, building rippled sand waves and low banks. Oid shoals form through gentle but constant agitation by currents and waves. The grains knock against each other, polish each other, grow layer by microscopic layer. The shoals shift and build over time, creating underwater dunes that rise just slightly above the seafloor, gentle undulations in the tropical shallows. On high plateaus where frost is intense, rock shatters into angular blocks that scatter across the surface. This is called a block field, and it creates a jumbled carpet of broken stone covering the summit. Over time, lichens colonize the blocks, softening their appearance and helping to weather them further. The block field settles, stabilizes, becomes a permanent feature, gently undulating, surprisingly stable despite appearing chaotic. Walking across one feels like crossing a stone river frozen mid-flow. And finally, along certain high-latitude coasts, especially near fjords, repeated freeze-thaw cycles combined with wave action have created something unusual. Wide, low, rocky platforms called strand flats stretch along the shore, nearly at sea level. These form through countless cycles of ice expansion and wave abrasion, planing the coastal rock into broad, flat aprons. Strand flats fringe dramatic, high-relief coasts with these gentle platforms, creating a buffer zone between mountain and sea. Their smooth transitions, abraded patiently by ice and water working together over thousands of years. Rest now. Sink deeper. Picture tufa mounds growing around springs, mud flats expanding tide by tide, granite domes being rounded by exfoliation, block fields scattered across cold summits. Everything changing slowly, everything shaped by repetition and time. There's no urgency in these processes, no haste. Just the steady, gentle transformation of stone and soil, water and ice, working together to reshape the world, grain by grain, layer by layer, year by patient year. Let that patience enfold you. Let it slow your thoughts. Let it carry you gently toward sleep. We journey onward through the Earth's quietest transformations. Let yourself settle even more deeply now, your breath slow and rhythmic, as these gentle stories unfold like waves lapping at a distant shore. In tropical hills, iron oxides dissolved in groundwater bind gravels together into hard sheets called ferrocrete. These iron-rich caps resist erosion far longer than the softer soil beneath them, creating flat-topped hills that stand above the surrounding lowlands. Ferrocrete forms through gradual leaching, water carrying iron downward through the soil, then precipitating it out in concentrated layers. Over time, these become armor, protecting the hilltops while everything around them slowly washes away. The result is a landscape of mesas and plateaus, capped with rusty red stone. High in the mountains, where snow lingers in sheltered spots, something subtle happens each spring. As snowbanks melt, the water erodes small basins at their edges, deepening them millimeter by millimeter with each melt season. This process, called nivation, creates hollows that are the beginnings of valleys, proto-valleys on gentle alpine slopes. Over decades and centuries, these hollows grow deeper, wider, shaped by the patient work of seasonal snowmelt, their cradles carved by snow, year after patient year. Along the coast, longshore currents carry sand parallel to the shore, and sometimes this sand extends outward from headlands into the water. These sandy fingers, called spits, curve gently as they grow, often hooking around toward the shore to enclose quiet lagoons behind them. Spits grow steadily, grain by grain, as currents deliver more sand. They create sheltered waters, calm places where boats can anchor and birds can nest. The spit is a gift from the currents, a gentle enclosure, a protective arm reaching into the sea. In some places, differential erosion strips away softer surrounding rock, leaving behind cores of harder granite. These become Bornhards, smooth, rounded domes of bare rock rising from subdued plains. They're isolated, bald hills, often symmetrical, their surfaces polished by weathering and sometimes by the exfoliation of outer layers. Bornhards stand like sentinels, alone in flat country, testament to the selective work of erosion that removed everything but the hardest stone. They're gentle giants, rising softly from the surrounding landscape. In coastal salt marshes, tidal creeks bring sediment with each tide. The water slows as it spreads across the marsh, and silt settles among the roots of marsh grasses. The grasses trap more mud, and slowly the marsh surface rises. This vertical accretion happens tide by tide, season by season, until vast, level platforms stretch for miles. Neither quite land nor quite sea, but something in between. Salt marshes are liminal spaces, built by the patient accumulation of sediment and the steady growth of plants working together. In swampy waters, especially in peatlands, iron bacteria perform quiet chemistry. They precipitate iron from the water, forming spongy nodules and masses called bog iron ore. This builds slowly, layer by layer, creating low mounds in the wetland. It's an example of life-mediating geology. Bacteria concentrating minerals, building deposits through their metabolic activity. The iron is soft, porous, rusty brown, and it accumulates wherever the chemistry and biology align. A gentle partnership between microbes and minerals. On bare limestone surfaces, rainwater etches fine grooves as it runs down the rock. These grooves, called rillenkarren, form subtle networks of parallel channels, each one just millimeters wide. Over centuries, they sculpt smooth pavements on karst exposures, the limestone becoming fluted, textured, inscribed with the paths of countless raindrops. Running your hand across rillenkarren feels like touching the fingerprints of water. Delicate, regular, persistent. In permafrost regions, sometimes underground ice grows in lenses that expand and push the surface upward. This creates pingos, conical hills that dome the tundra, rising gradually over decades to heights of 50 meters or more. As they grow, their summits crack under the tension of being stretched. Pingos are ice-cored mounds, evidence of hidden forces working slowly beneath the frozen ground. They rise like gentle volcanoes, but of ice rather than fire. Sometimes waves and currents build sandy connections between islands and the mainland. These are tombolos, isthmuses of sand that link what was once separate. Over time, waves widen and strengthen these connections, creating continuous, gently arched coastal paths you can walk along. The island becomes a peninsula, connected by this gift of sand, this bridge built by waves working patiently over centuries. And finally, where rock layers of different hardness tilt at an angle, differential erosion creates something asymmetric and beautiful. The softer layers erode away more quickly, creating steep scarps on one side, while the harder layers form long, gentle backslopes on the other. These are cuestas, ridges that have one steep face and one gentle slope. The gentle side, the dip slope, can extend for miles, a smooth ramp following the tilted rock layers. Cuestas create distinctive, asymmetric landscapes sculpted by the selective action of erosion on layers of varying resistance. Breathe slowly, rest deeply. Think of iron caps protecting hilltops, snow carving mountain hollows, sand spits curving into bays, ice lenses lifting the tundra, everything moving at its own measured pace. The earth is never still, but its motion is so slow, so patient, that it becomes a form of stillness, a dynamic peace. Let that peace settle over you like snow settling on a quiet hillside, like sediment drifting down through still water. There's nowhere you need to be, nothing you need to do. Just rest here, in the slow time of geology, where change happens so gradually it feels eternal.